They're turning off the most powerful machine on Earth. Why would scientists shut down a $10 billion experiment that unlocks secrets of the universe? Is something wrong? The short answer is no. The real reason is even bigger, bolder, and honestly, kind of insane. And what comes next could change physics forever. Big news is spreading fast. The Large Hadron Collider is being switched off. For some people, that sounds scary. Over the years, rumors claim this giant machine might create black holes or even destroy the planet. So when people hear it's shutting down, they wonder, is this the end? No, not even close. The truth is far less dramatic and far more exciting. The Large Hadron Collider, or LHC, is the biggest and most powerful scientific machine ever built. It sits deep underground near Geneva, right under the border between France and Switzerland. From above, you would never guess what lies below. But 100 meters underground is a massive circular tunnel stretching about 27 kilometers around. Inside that tunnel, scientists do something incredible. They smash tiny particles together at almost the speed of light. Why? Because when these particles collide, they recreate conditions similar to what existed just after the Big Bang, the moment our universe began. For a tiny fraction of a second, scientists can study what reality looked like nearly 14 billion years ago. That is not science fiction, that is real. The project began in 1989 and officially started operating in 2008. It cost around $10 billion and involved thousands of scientists from all over the world. Well, the organization running it is called CERN, short for the European Organization for Nuclear Research, and the LHC has already made history. In 2012, it confirmed the existence of a particle scientists had been searching for since the 1960s, the Higgs boson. This discovery was huge. It helped explain one of the biggest mysteries in physics. Why do things have mass? Here's a simple way to think about it. Imagine you put a rock on a scale. It has weight. It has mass. Now imagine light. You can't weigh light on a scale. Light is made of particles called photons, and they don't have mass. So why do some particles have mass while others don't? Scientists believe there is something called the Higgs field that fills the entire universe. You can't see it. You can't touch it. But it's everywhere. Some particles move through this field easily, and are like a swimmer gliding through water. Others struggle more, like someone trying to run through thick mud. The more a particle interacts with the Higgs field, the heavier it becomes. The discovery of the Higgs boson proved that this field is real. But that was not the end of the story. In fact, it was just the beginning. Even today, scientists still don't fully understand why different particles have such different masses. They don't fully understand how Higgs bosons interact with each other. And they definitely don't understand dark matter, the invisible stuff that makes up most of the universe. That's why the LHC is being turned off. Not because it failed, not because it's dangerous, but because it needs an upgrade. Over the next several years, engineers and scientists will transform it into something even more powerful, the High-Luminosity Large Hadron Collider. What does high luminosity mean? In simple words, it means more collisions. Right now, the LHC smashes particles together billions of times per second. The upgrade will increase the number of collisions by about 10 times. That means more data, more rare events, more chances to discover something completely new. To make this happen, they are installing stronger superconducting magnets. These magnets guide and squeeze the particle beams so they collide more precisely. They're also upgrading the detectors, giant machines that record what happens during each collision. Think of it like upgrading a camera from standard definition to ultra-high definition. You don't just see more, you see clearer. This shutdown will last several years, and this is not the first time the LHC has paused. It already went through major shutdowns in 2013 and 2018 for maintenance and improvements. Nothing bad happens when it powers down. It simply rests while engineers improve it. But here's where things get really interesting. The LHC will not run forever. Scientists expect it to operate until around 2041. After that, it will likely retire. And that's when the truly massive plan begins. CERN is proposing a new machine called the Future Circular Collider, or FCC. If built, this machine would make the LHC look small. Instead of 27 kilometers around, the new tunnel would stretch about 91 kilometers, more than 3 times larger. It would be dug even deeper underground, forming a giant ring beneath the countryside, and it would be built in 2 stages. The first stage would collide electrons and positrons. A positron is basically the antimatter twin of an electron. When matter and antimatter meet, they release pure energy. Studying these collisions would allow scientists to examine particles like the Higgs boson with incredible precision. Then in the second stage, possibly decades later, the collider would smash protons together at energies about 7 times higher than today's LHC. 7 times more powerful. Why go that far? Because some particles might be too heavy to appear in current experiments. If dark matter is made of unknown heavy particles, we may need much higher energies to create them. The FCC could give us that chance. Of course, building something this large is not simple. The estimated cost for the first phase alone is around $18 billion. That number is enormous. Understandably, some people question whether it's worth spending that much on particle physics. But history shows that big science projects often lead to unexpected benefits. For example, the World Wide Web was invented at CERN. Advances in medical imaging, computing, and superconducting technology also came from particle physics research. When humans push the limits of knowledge, new tools and ideas often follow. The FCC is still under review. CERN has completed a detailed feasibility study showing the project is technically possible. Around 2028, decisions will be made about whether to move forward. If approved, construction could begin in the 2040s. So when you hear that the Large Hadron Collider is shutting down, remember this: it's not the end. It's part of the process. Science doesn't stand still. It upgrades. It evolves. It aims higher. And about those scary rumors? Some people worried the LHC could create black holes, strange matter, or dangerous vacuum bubbles. Scientists carefully studied those possibilities before the machine ever turned on. The conclusion was clear. There is no realistic threat. Nature already performs much higher energy collisions every day. Cosmic rays from space smash into Earth's atmosphere at energies greater than the LHC can produce. And Earth is still here. The LHC is powerful, but it's safe. So why does all this matter? Because at its core, this machine is trying to answer the biggest questions humans can ask. What is everything made of? Why does matter exist at all? Why is there more matter than antimatter in the universe? What is dark matter? These are not small questions. They are the foundation of reality. And every time scientists increase the power of these machines, they push the boundary of what we know. Imagine if we stopped exploring because it was expensive or difficult. We would never have crossed oceans. We would never have gone to space. We would never have built the technologies we now use every day. The LHC proved the Higgs boson exists. That discovery completed something called the standard model of particle physics, our best theory explaining how tiny particles behave. But the standard model is not complete. It does not explain gravity properly. It does not explain dark matter. It does not explain why the universe expanded the way it did. There are gaps, and science moves forward by finding those gaps. The High-Luminosity LHC will collect more data than ever before. It will test the standard model with extreme precision. If tiny cracks appear in the data, small differences from what theory predicts, that could point to new physics. And the future circular collider, that could open an entirely new chapter. One day, students learning physics might look back at this moment and say, that's when everything changed. Right now, we are watching a transition, the end of one era, the beginning of another. If you enjoyed this deep dive into the future of physics, make sure to like this video and subscribe to the channel so you don't miss the next big breakthrough. Because the universe still has secrets.